Okay. Hello viewers, this is Mr. Banda of Mathematics Made Easy. So in today's lesson, we are going to look at indices. Now, we have quite a number of questions here with regards to the topic of indices. And these are questions coming from Mathematics Syllabus D, that is ECZ Syllabus D. Now, these questions are involving quite a number of concepts with regards to indices, because indices, yes, as a topic, it has quite a number of concepts we are supposed to understand. Now, before we go any further, looking at how these questions can be tackled or solved, I have just brought a few rules of indices I feel we are supposed to discuss, because most of these questions I usually dwell on the rules of indices, and I believe these are going to help you. So the first rule of indices, or maybe before I even talk about the rules of indices, let me maybe just have a simple definition of an index. So an index, whose plural is indices, is defined as a value, or variable written in the form a to the power n. So this is called an index, and the plural of index is indices. Now, this is a value or a variable written in the form a to the power n, or given in the form a to the power n, where a is called the base. So this is the base, and n is called the exponent. The exponent or index, or the other name is power. You can say power. So n is called the exponent or index or power. So this is what an index is. Now, take note of these terminologies, because in most of my discussion here, I'll call n as the exponent and I'll call a the base. When I say the base, you know what exactly I mean. And when I say the exponent, you'll be able to recognize what I'm talking about. So that's what an index is. Now, the rules of indices are that the first rule is a rule that tells us that when you're multiplying two indices having the same base, regardless of the indices being different or being the same, what you do is you're just going to maintain the base and you add the indices. So what you're saying is a to the power n multiplied by multiplied by a to the power m. So you can see here that the bases are the same. We have base a here, and there we have base a, and the exponents are different, but they may also be the same. It doesn't break n bonds. So a exponent n multiplied by a exponent m, what you're going to get is just a exponent n plus m. So we are saying that when you're multiplying two indices having the same base and different or same exponents, you just maintain the base and add the exponents. And the second law is talking about when you are dividing now. When you have a to the power n divided by a to the power m, what is the implication here? So what it means here is that you are just going to maintain the base, but with the powers you subtract. So this is a to the power n, or a exponent n minus m. That's what we have there. Okay, the third law talks about the meaning of a to the power, so when you have ab to the power n, so you have two bases raised, or a product of two bases raised to the same power. So the meaning here is that you distribute the power to these two bases. So that will be a to the power n times b to the power n. Okay. The fourth rule is the rule involving a base raised to the power n, and the same base is raised to the power m. Okay, when you have an index with a power, or an index with the exponent raised to another exponent, the meaning here is that you are going to maintain the base as a, then you multiply or distribute the index which is outside, or the exponent which is outside, to n. So you have n times m, which will give you a and m. Okay, so these are rules of indices. The fifth rule we can add on is the meaning of a to the power a fractional index. When the index is a fraction, what does that imply? So when you have a to the power, let's say a to the power x over y, okay, the meaning here is that our y is going to be the root, or the nth root, and x is going to be the power. So the meaning here is this is a, or this is the yth root, because we are using y, not n. So this means yth root of a raised to power x, or yth root of, so we're saying that yth root of a power x, or exponent x. So what we are saying is that the numerator is the exponent, and the denominator here will be the root. Okay. The sixth, we have a to the power 0. What is a to the power 0? You know, this will always give us 1. The reason is simple. This can be checked. You can check that this will be 1 using this rule here, rule number 2. Okay, you understand 0 as an additive unit, or additive identity. So a 0 is just a value that you get when you find the difference of two identical numbers, or variables. So a minus a will give you 0, b minus b will give you 0, n minus n will give you 0, 2 minus 2 will give you 0. So this is coming from the fact that 0 is the same as n minus n. Okay, so when you are saying a to the power 0, you mean a to the power n minus n. Now, a to the power n minus n, by this rule, implies that a to the power n divided by a to the power n, which will be a to the power n over a to the power n. This must give you 1. So this is the reason why a exponent 0 is equal to 1. So just thought of explaining that so that we can easily understand mathematics in such a manner. So this is what we have. Is there any rule that we have left out? Yes. What about a scenario or a situation when we have a negative exponent? So you have a to the power negative n. Okay. So a to the power negative n. This negative implies that we are supposed to reciprocate, or find the reciprocal of the base. Then you raise that in brackets, raise that to power n. So negative, the implication of negative is that this base, you have its reciprocal, or you reciprocate the base. And you know the meaning of reciprocating the base. It means that you get the multiplicative inverse, in other words, of the base here. So the base is a. The multiplicative inverse of a is 1 over a, then raised to power n. Okay, this is going to give us 1 over a power n, because you know that 1 power n is 1 and a power n. So you distribute also the power over division here. You are dividing, so you distribute the power n to the numerator and the denominator, and you get this. Similarly, this can lead us to this other rule, which is telling us that when we have a over b, so our base here now is a fraction, okay, to the power negative n. So this is going to be equal to, you reciprocate, just like we did when we had just a whole number there, or a decimal. So what it means here is you reciprocate. This is going to be b over a. We are reciprocating here because we have negative, and whatever we have there, you raise it to power n. Then you distribute the power. That will be b power n over a power n. These are the rules guiding this concept of indices, and I believe you have understood what we have here. Now, coming to the questions that we have here, how do we solve this particular question? Questions. So let us look at the working for each of the questions we have on the board here. What are we supposed to do to find the solution to the questions we have here? So that's for the working. So the first question is saying, can you evaluate 3 over 2 to the power negative 2? This is coming from 2022, paper 1. So we are saying, question 1, we have 3 over 2 to the power negative 2. Okay, so using the rules of indices, like I've indicated, that when you have a negative index or exponent or power, you have to reciprocate the base. So the base is 3 over 2. So meaning this is going to become 2 over 3. You reciprocate, then raise to power 2. Okay, the meaning of this is 2 power 2 over 3 power 2. You distribute the power over the base, the fraction that we have. And this is going to give us 2 to the power 2. The implication there is you are multiplying 2 by itself twice. That's what squared means. So 2 to the power 2 is 2 times 2, which is 4, over 3 to the power 2 is 3 times 3, which is 9. Then you are done. So that will give you 4 over 9. All right, let us look at question 2. It's saying, can you solve the equation 2 to the power 2x to the power 3 being equal to 16? Now, take note here that for us to solve this particular equation, this is an equation involving indices, we should first simplify it. So how do we simplify? You can divide here by 2 and there by 2, or you can multiply by the multiplicative inverse of 2, which is 1 over 2 both sides. So this is going to give you x cubed, because 2 into 2 is 1, 1 times x cubed is just x cubed, being equal to 8. Okay, when you reach here, your goal is to raise both bases to the same power. So we have exponent 3 here, and you have 8 exponent 1 here. So you have to raise both bases to the same power. This is, or same exponent. This is x exponent 3 being equal to 8. Okay, what next do you do? So what you do here is this. This is x to the power 3. So you multiply both. You multiply both exponents by the multiplicative inverse or the reciprocal of the power of x in this case. So the reciprocal of the power of x is 1 over 3, because the power of x is 3. So its reciprocal is 1 over 3. So you multiply to the powers by 1 over 3. So this will be x power 3 times 1 over 3 being equal to 8. This is power 1 because there is no another power there. It means that we have 8 power 1, then times 1 over 3. Okay, then you can see that this 3 will be divided by this 3. You just remain with x power 1, which is just x, being equal to 8. 1 times 1 over 3 is just 1 over 3. Alright, so this is equivalent to say x is equal to, now when you have a to the power 1 over 3, this is a fractional index which we have said in the rules of indices. So the base, which is, the denominator, which is a 3, will be the root, and the numerator, which is a 1, will be our exponent. So this will mean cube root, because the denominator is a 3, so you put a 3 here to mean cube root of 8, power 1. So that will be cube root of 8 power 1. So it means that x is equal to, what is the cube root of 8? What is the meaning of cube root of 8? We are not looking for a number that must be multiplied by 3 to get 8. No. We are looking for a number that must be multiplied by itself 3 times. You multiply it by itself, you multiply that particular number 3 times by itself, and it will give you 8. So the cube root of 8 is basically a 2 power 1, which is equal to 2. You then say, therefore, x must be 2. So you can check that when x is 2, then 2 times 2 to the power 3, 2 to the power 3 is 8. So 2 times 8 will give you 16. Then that's what we are required to do. Alright, so that was question 2. Let us look at question 3 from this part of the board. Question 3. So on question 3, we are saying, given that the square root of 2 is equal to 2 to the power x, find the value of x. So we are saying square root of 2 being equal to 2 to the power x. Let us solve for x. Okay, so if you want, you can start with 2 to the power x, because that's what we are looking for. The unknown there is 2 to the power x. So you have 2 to the power x being equal to the square root of 2. Okay. Now, take note that the square root of 2, square root means that what we have is that the square root, that's one of the rules that maybe I forgot there to mention, that the square root of a means a to the power 1 over 2. Because I've said the denominator here is a root. So when you have a 2 there, what you have is square root. When you have a 3 here as a denominator in your root, in your exponent involving fraction, or in your fractional exponent, the denominator here will be the root, and the numerator is the power or exponent. So a to the power 1 over 2 means second root, which is called square root. So when you have square root of 2, it means 2 to the power 1 over 2. Or 2 to the power 1 over 2 means square root of 2. So we are using this particular rule of indices. So this is going to be 2 to the power x being equal to 2 to the power 1 over 2. Now you can see here that the bases are equal. The base to the right hand side of our equation is 2, and the base to the left hand side of our equation is equal to 2. Now because of that, it means that even the exponents, if these two expressions are equal, if 2 to the power x is equal to 2 to the power 1 over 2, and the bases are the same, it means that the exponent, this can only be true when the exponents are equal as well. So If 2 to the power x is equal to 2 to the power or 2 exponent 1 over 2, it means that this x here, which is the exponent, is equal to the exponent there, which is 1 over 2, because the bases are equal. So there you just say x is equal to 1 over 2, and the equation is solved. Just as simple as that. No need to panic when you encounter such a question. Let's look at question 4. So question 4 is saying evaluate negative 3 squared plus 3 squared. This is coming from 2021 paper 1. Okay, the previous question also is coming from 2021 paper 1. Now we have negative 3 squared plus 3 squared. Okay, this is a question which looks so simple. Okay, but this question is a question examining us on our understanding of the meaning of negative 3 squared. Okay, now take note that negative a squared is not the same as negative a in brackets squared. The reason is simple, okay? Negative a squared means negative of a squared. Alright, it means negative of a times a. This is going to give you negative a squared. That's what we are saying. But the negative of a in brackets squared means you are squaring both this negative and the base there, which is a. So that means negative a times negative a. And negative times negative, it will give you positive a squared. So the meaning is different. So take note here that negative 3 squared will mean negative of 3 times 3. Negative of 3, what is being squared here is just a 3, not a negative. Okay, plus 3 squared means 3 times 3. So this will be negative of 3 times 3 is 9, so that will be negative 9, plus 3 times 3 is also 9. So plus 3 times 3, which is 9. What is negative 9 plus 9? This will give you 0. Mind you, these are different signs, negative and positive. And for you to add them, it means you have to subtract them and maintain the sign of the numerically bigger number. But in this case, you don't have any bigger number. This is 9, that is 9. So it will give you 0. Okay. So that's what must be done in question 4. Let us look at question 5. Then we'll look at the last question, which is question 6. So question 5. Question 5 is saying, can you evaluate 64 over 125 exponent negative 1 over 3. This is coming from 2020 GCE paper 1. So 64 over 125 exponent negative 1 over 3. So what we do here is, do not forget the rules of indices. We understand very well now that when you have 64 over 125, for you to do away with the negative is telling us that we should reciprocate. Let us get the multiplicative inverse of the base. So the base is 64 over 125, whose multiplicative inverse or reciprocal is 125 over 64. So this is what you are going to have to the power now 1 over 3. The moment you reciprocate, you do away with the negative index. It will remain positive. Then now we get back to the other rule of indices that tells us that when you have a fractional index, the denominator is the root. So this will mean cube root of 125 over 64. Okay, cube root of 125 over 64 to the power what? To the power 1, because the numerator is a 1, which is the power in this case. So this will mean cube root of 125 divided by cube root of 64. So this is coming from everything to the power 1. This is coming from a rule that I didn't add there, that if you have a over b to the power, when you have square root or cube root of a over b means square root of a over b means square root of a over square root of b. So this means one and the same thing. So that's what we are going to do there. Now, because cube root of 125, we are looking for a number that we can multiply by itself 3 times, and it will give us 125. And this is a paper 1 question where you are not using a calculator. You know how to get the roots. You can either use the concept of expressing 125 as a product of its prime factors. That is going to give you a 5. You check. So the cube root of 125 is 5 over the cube root of 64. Check that will give you 4. You can write 64 as a product of its prime factors. Later on, this will give you 4 times 4 times 4. Okay. So this will give you 5 over 4 to the power 1, which is equal to 5 over 4. And you can write this as a mixed fraction. It will give you 1, remainder 1 over 4. Because 4 into 5, 1. The remainder is 1 over 4. So this is what this particular value will give us. When you evaluate this, you get one more number, 1 over 4, or 5 over 4 as an improper fraction. Alright, now we are winding up. We are now winding up by looking at the last question, but not the least, as it contains a very important concept as well, which I believe is going to be of help to you. So that's question 6, saying, given that 8 to the power x minus 1 is 16, find the value of x. This is coming from 2020 GCE. So the question is 8 to the power x minus 1 is giving us 16. Let us solve for the value of x. Alright, just like we tackled this particular question here, though this is quite different, owing to the fact that what we don't know there was the base, and there what we don't know is the exponent. We are going to apply the concept that we used here. Now, what do you do here? This is 8, base 8 to the power x minus 1, and this is base 16 to the power 1. So, when the unknown is the exponent, and the bases are different, we have to strive to write the bases as indices having the same base. So we have to look for the common base of 8 and 16. So how can we express 8 to a base that we are able to express 16 also? Alright. So 16, let's look for the common base. It is very easy for us to think that we can write 16 as a number to base 8, which is not true, because you cannot multiply 8 any times to get 16. So the common base here cannot also be a 4. It can't be a 4 because you cannot write 4. You can't multiply 4 by itself any times to get 8. You can't multiply 4 by itself any times. Yeah, you can. Here you can multiply 4 2 times by itself and you get 16, but you won't do that to get 8. It is the same reason why we can't use 8. We know here you can multiply 8 once by itself, so you just have 8, but you can't multiply 8 n times to get 16, where n is an integer, positive integer, so to say. So in this case, let us look and think through the best value, okay, which is going to give you a 2 if you have thought through it. you know that you can write 8 as 2 times 2 times 2, meaning 2 to the power 3, that is 8. And you can write 16 as 2 times 2 times 2 times 2, which is 2 to the power 4. Because of that, 8 to the power x minus 1 can be written as 2 power 3, this is 8, then power x minus 1. This is equal to 16 is 2 power 4. So now that we have a common base on the left-hand side of our equation and right-hand side of our equation, we now work on the exponents. How? So when you have 2 power 3, and we have another power here, as I explained in the rules of indices, you distribute the power. Okay, so this is going to be 2 power 3 times x minus 1. So you multiply this power and the power that we have inside, this giving us 2 power 4. Now, do not forget what I said, that if the bases are the same, okay, the base on the left-hand side is equal to the base on the right-hand side. So here you have 2 exponent 3 x minus 1 in brackets being equal to 2 exponent 4. It means that the exponents are equal. Okay, if the bases are equal, the exponents are also supposed to be equal. So we are saying that 3x minus 1 will be equal to the exponent there, which is also 4. So this will be 3x minus 3 times x, 3x, 3 times negative 1, negative 3, giving us 4. Then you have 3x giving us 4 plus 3. When you add the additive index of negative 3, in this case, which is positive 3 both sides, and you reach here, you have 3x being equal to 4 plus 3, 7, divide by 3, divide by 3. Then x will be 7 over 3, which is equal to 3 into 7, you get to go there twice, so it will divide 7 twice. And the remainder is 1 over 3 as a mixed fraction. This is what you do. A number of us usually get stuck when you reach here or here, okay? Okay, or maybe even just to come up with a common base. That's where an issue is, but it's quite easy. You're just looking for a number that you can multiply by itself n times and it will give you 8. And the same number you multiply by itself n times and it will give you 16. That is a common base. Okay, any may be a different value in that case. So when you reach here, just equate. This will be equal to that. Then solve for the equation. Some usually get confused how from here they reach. They go to this stage. So when you have this, the concept there is simple. If the bases are the same on the right-hand side and on our left-hand side, and the bases are equal, then the exponents, if these two sides are equal, then the exponents are also supposed to be equal. So that's the concept that we're using here. If 2, the same 2 raised to this exponent is equal to the same 2 raised to that exponent, it means that this exponent is equal to that exponent. So you equate them and solve for the unknown variable. In this case, it was x, and it gave us 2 to the power, 2 whole number 1 over 3 fraction. Thank you so much. I hope and believe that you enjoyed this lesson to do with indices. And for you to enjoy some more lessons to come, please subscribe to my YouTube channel that you may learn and get help with so many concepts in mathematics. We cannot disregard the fact of how great value mathematics has in this world. Not only to the world, but also to humankind. It is important that we understand mathematics fully, not just as a set of rules, but as a set of beautiful and interconnected beautiful concepts, and out of it we'll be able to appreciate mathematics and life in general, because life is surrounded over beautiful concepts of mathematics. Thank you so much. God bless you all.